Alright, this is the second presentation on subtraction. If you have not watched the first video on subtraction and the video on negative numbers, that'll probably help make all of these points make sense. We're going to be talking about the subtraction algorithm, which is the steps that we would normally jump to when we were given a problem like this. We would typically stack those numbers on top of each other, and then we would subtract the ones place, the tens place, and the hundreds place. And while this is correct, we're going to break down those steps to understand how the properties that we've already seen in previous videos allow that to work. So the first thing that we need to recognize is that there's really no point in just kind of mindlessly using the same algorithm if we don't understand where it comes from and why we're able to use it, why it works. So, to kind of break down those steps, the first thing we would do is expand these numbers. And we would say, okay, well, 675 is 600 plus 70 plus 5. 241 is 200 plus 40 plus 1. So we wind up with 675 expanded minus 241. And here we have our problem. If we remember, we can't just use the associative property and get rid of those parentheses. I actually demonstrate, if we tried to, we clearly would not get the correct answer. So let's go ahead and write out what the subtraction algorithm actually is. The first thing we would do is we would say, okay, well, 5 minus 1, that's 4. So we're saying 5 minus 1. We're subtracting the ones place. Then we would say, okay, 70, right, that's the tens place. 70 minus 40, well, that's going to equal 30. So 70 minus 40 is 30. And then 600 minus 200, well, 600s. If you take away 2 of those hundreds, you're left with 400s. 600 minus 200 is 400. And then, once we get those numbers, we just add them together, right? 400 plus 30 plus 4, or 434. So, without performing the actual subtraction, we have 5 minus 1, the ones place, plus 70 minus 40, the tens place, plus 600 minus 200. Or we can rearrange these three terms to put it as 600 minus 200, plus 70 minus 40, plus 5 minus 1. Which does, in fact, give us the correct answer, 434. The problem is, how did we get from here to here? This is our hypothesis, that 675 minus 241, the original problem, is equal to our algorithm, 600 minus 200 plus 70 minus 40 plus 5 minus 1. And keep in mind, all this is us performing subtraction of each place value. Well, what we're going to do is we're going to kind of group these into terms. We're going to say 675 is a term. 241 is a term. We'll call this A and we'll call this B. And then this whole thing here, we're going to say that this is one term. We're going to group all this together as one term. Because ultimately it comes together to be one number, right? 434. So now we have A minus B equals C. And this should look familiar. This is the beginning of one of our properties. We have this property that says when we have A minus B equals C, then C plus B is going to equal A, right? If we have A and we take away B and we get C, well, if we add B back to C, we're going to wind up with A. So to rearrange what we have here to C plus B equals A, we have the actual hypothesis, the subtraction algorithm, plus 241, that second number, and that should come out to equal A, right? All that we've done is just followed the inverse property. Now that we've set it up this way, notice that this term, plus this term, plus this term, plus this term, this is all addition. And since we even just have addition here of terms, we can use the associative property and say we can get rid of these parentheses. We don't need to leave the parentheses around 200 plus 40 plus 1. And once we get rid of those parentheses, we still are just adding terms. This plus this plus this plus this plus this plus this. So we can also use the commutative property of addition. And we're going to move the 200 over here. And we're going to move the 40 over here. And we're going to move the plus 1 over here. And now we have 600 minus 200 plus 200. 70 minus 40 plus 40. And 5 minus 1 plus 1. And hopefully you see another property that's about to get used. The cancellation property, if we remember, it says if you've got some number A, and you take away B, and then you add B, well, you're just back to A. Well, here, 600, that could be A. We're taking away 200 and then adding 200. That just cancels itself out. That goes back to 600. So we have 600 plus Well, minus 40 plus 40, that cancels out. So 600 plus 70 plus, well, minus 1 plus 1, that cancels out. So 5. So 600 plus 70 plus 5. Does that equal 600 plus 70 plus 5? Yeah, absolutely. That's what we just said. We can clearly see those two things are equal. They're the same thing. And so that proves that that subtraction algorithm, our hypothesis, is true. This came out to be a true statement. To put that all together, we expanded, we used the inverse property, we used the associative property to get rid of parentheses, and the commutative property to rearrange our terms. Then we used the cancellation property to get us back to these two things, which are clearly equal. I've done the same thing here, except for we just used different numbers, and you can pause the screen and follow through these steps, but we expanded, we used the inverse property, associative, commutative, the cancellation property, and once again we get the same answer. And now what we're going to do is we're actually going to jump to an algorithmic proof. We're going to say, I bet this works all the time. We don't really need to use numbers. If we have L plus M plus N, and keep in mind this is, I'm going to go back, this is just 574. This is any number expanded out. This is assuming a 3-digit number, but we could do it for a 5-digit or a 20-digit number. But we have L plus M plus N, and let's just assume this is the hundreds place, the tens place, and the ones place. And if we subtract X plus Y plus Z, which would be the other number expanded, then it is going to equal our subtraction algorithm, which says, hey, you should subtract the ones place, and then the tens place, and then the hundreds place. We rearrange it using the inverse property. We get rid of the parentheses, so we use the associative property. Then we use the commutative property to move those terms, cancellation property, and we're left with L plus M plus N equals L plus M plus N. Since these two things are equal, then that subtraction algorithm must have worked. So I put back some of the numbers, but now I've given you a new problem that I want you to do. So you can just pause, and this is just a reference for you to kind of guide you through the process. Here's another one I want you to do. This time I just gave you the the algebraic proof, but it still is going to guide you through the steps. 500 plus 40 plus 3 minus 100 plus 20 plus 3 equals 500 minus 100 plus 40 minus 20 plus 3 minus 3. And then I give you one more, and I want you to do this one on your own without having to use the algorithm. Without having to use the steps that I gave you on the previous slide. And the last thing we're going to do is we're going to talk about borrowing. We get to a problem like this, and we say, well, I can't take 5 away from 3. That's not possible. And I think we know that typically we would strike out the 6, make it a 5, turn this into a 13. Which works. Once again, that's a great way to do it. It's fast, but we need to, why can we just randomly make the 6 a 5 and the 3 a 13? To do that, we're going to look back. This was the proof we did on the first day in the first video for carrying in addition. And remember, when we came up with in our ones place, we had 15, and we said, well, we can't have 770 15, but we can break 15 apart and move that 10 to the tens place, and we're left with 700 plus 80 plus 5, or 785. When we borrow, we kind of do the opposite. 563 minus 291, well, 3 minus 1, if we stack those, would be 2. But 6 minus 9, we can't do that. But what we can do is we can say, well, 500 is the same thing as 400 plus 100, right? And then this is all addition right here, so we can use the associative property to regroup. We can say, okay, it's actually 400 plus 100 plus 60. Well, what is 100 plus 60? We have 400 plus 160 plus 3. Well, now, if we say, what's 160 minus 90? Well, we get 70, right? And now, over here, we have 400 minus 200, and that gives us 272 for our final answer. So that's just a demonstration of why borrowing works. So I give you this problem. I want you to do the same thing. There's another problem, and one more without the steps laid out for you to do on your own. And that's what we're covering when we're talking about this second presentation of proving the subtraction algorithm. That's what we've just done. Thank you very much.